Okay, hey geometry class. Hate that I was not able to be with y'all today. I'm gonna try to cover this lesson in a video, and if you have the original Matthew C videos, go ahead and watch lesson 24, proving triangles congruent using side, 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 and side angle side postulates. We'll watch it again next week, but with proofs, it doesn't hurt to watch it a few times. So this is a new concept. We've been talking about it for a while, and then the week we get to introduce it, my daughter's 6, so that stinks. But we're going to get a lot of practice over the next several weeks, so this will not be your first time or last time seeing it. So what I have written on the board is a proof, and I have sent you a piece of paper for notes, 2 blank proofs that I'm going to work through. Print this off, write on it, fill it out. If you want to stop, do that real quick. It should be in the email. Do that. You can also make one on a piece of paper if you want, but if you want to just have it, the figure already drawn out, pretty simple. Just go ahead and print that off. Okay, so the first thing just want to establish is when we are proving triangles congruent, we can do that multiple ways. There's postulates or different things that we can say, well, these are all the same, and if these are the same, then a triangle is congruent. So a triangle has 6 parts, has 3 angles, and has 3 sides. You can have a triangle facing, make sure I'm in the video, this way, and this way. And we could say these sides are the same, these are the same, and these are the same. And because all these sides match up, we can say, even if they're facing a different direction, we could flip them around and they would match up. So we would know that these are congruent or the parts match up. We can do the same thing with angles. And when sides are going to be the same, the angles in between them will end up being equal or congruent as well. So that's the first thing, is just understanding triangles, being able to flip them around, understanding congruency. And then getting used to spatially being able to turn that around. This last lesson with corresponding parts kind of got you used to that. And that was the point of that, is to see what line matches up with what line, so that you'll be able to see that a little bit more easily when you're doing proofs. Okay. So 2 different ways that we can prove a triangle is congruent that we're going to be introduced today. One is called the side, side, side postulate. So SSS is the quick way to write that, and then postulate. So pretty much saying if this side is equal to this side, that side's equal to that side, this side's equal to this side, then this is the same triangle. They are congruent. They match up exactly. But being able to prove that they are takes a little bit of math, or a little bit of our geometry knowledge. So that printout from lesson 22 about the fill in the blanks of all the different theorems, make sure that you've read that you know those, because the more acquainted or well equipped you are with those, then this will not be as hard, because you'll understand, well, what's a rhombus, what does that mean, and I can see it a little bit more easily. Okay, so when you get a proof, this is what you're going to see. You're going to have a figure drawn for you. You're going to be given some information, just like we've been seeing in some of our other examples, and we did it especially earlier in the year with angles. So here we are told that QRST, so this shape here is a rhombus. Which makes me think, what do we know about a rhombus? Well, in a lot of times thinking about what's the definition of a rhombus. So if you look at those theories that we have printed out, a rhombus states that all sides are congruent. So even from that, we could say, well, I know this is equal to this, is equal to this, is equal to this. All those are the same. And a lot of times we use those same little marks just to show what is equal to what. You're going to, number 3, be told, what do you need to prove? So we need to prove here, by the end, that QRS is congruent to triangle QTS. That if I flip that up, those are matched right on top of one another. So a lot of times, if that's what we're going to be proving, we can write that at the very bottom. Of course, we don't know how much space we're going to need, but that could be the last statement that we have and then our reason. Right now, we don't know a bunch of reasons that triangles are congruent. And I already told you we're going to be using side, side, side postulate. So that will be what we're using here, but we'll get to that in a second. So a lot of times we start with what's given, and then we build a case. In the video, he talks about going to court. You might know a piece of information, someone else might know it, but until the evidence is actually given in court or to said out loud, it is not common knowledge. It's not all known. So we might see this and think, oh, that looks like a rhombus, but until it's given QRST is a rhombus and it's put up here, then can we start working and establishing what we want to prove or build our case. So let's start with what is given to get to those triangles are congruent. And we're going to look for 3 sides that are the same. So I'm just going to walk you through this first one. So the first thing is QRST is a rhombus. That's my first statement. My reason is that it is given. I'm told that this is a rhombus. So from that, what can I say? Well, I already showed you that means all the sides are equal. So you could say, and you want to make sure that the sides are corresponding to each other, you could say that QR is equal or congruent to QT side. So QR is congruent to QT. That would prove one of my sides. The reason I can say that is because of definition of a rhombus. Rhombus says that all sides are congruent. These are the sides. They're congruent because of the definition of a rhombus. Okay, what about my other side that was given? RS and TS. Well, I could say that those are congruent. That those sides are because of definition of a rhombus again. And I'm okay with you doing the little marks like that as long as it's clear and readable. Okay, so I've stated that these are equal, these are equal. The last thing I have is this baseline right there. The thing is that it is the other side to both of the triangles. So I could say QS line segment is equal to QS. That would prove that'd be my last side. Now, what allows me to state that? What does that look like? Which property? QS is equal to QS. Remember we said A is equal to A? It's called the reflexive property. So the reflexive property lets me state that QS is equal to QS, or this is equal to itself. So then I've proven that this side is equal to this side, this one's equal to this one, and this one is equal to this one. So I have a side, side, side. By showing that, I showed that all my sides of my triangles are congruent. Therefore, my triangles are congruent to one another. And I use the side, side, side postulate. Okay, so that fits on the last one if you can see it. So this would be my proof. I gave all my statements, I gave my reasons using what we know about geometry, and my final statement is what I proved, and a lot of times your first statement is going to be what's given.